Hey, good morning, everybody. Good afternoon. So I'm here to talk about Kubernetes today. So it's going to be, a real quick session. It's going to go over some basic concept of, some Kubernetes constructs, what Kubernetes is, and what it consists of. So, quick introduction to this. Kubernetes came from Google. If you didn't know, so it was open source out of Google from a project called Borg. And so Borg actually is not the same code base as Kubernetes, but it's similar in the constructs and how Borg worked as far as how it handled container workloads. Okay, but it provides just a scalable way to deploy and predictably scale out container workloads, and it's basically a container orchestration framework as far as deployments, upgrading deployments, scale your applications on the fly, being able to provide rolling updates into container workloads, roll out new features. So from one version to the next version, it's very simple to do that with a Kubernetes framework, just because of the way of it handles it, as far as being able to orchestrate the pods on top of Kubernetes, right? So if you think of this like in the VM form factor, where DRS and HA constructs that vSphere have, it's very similar in that, where Kubernetes is actually scheduling containers instead of VMs, but it's also providing things like high availability, and we'll walk through how that works. It's optimizing your resources, so containers are typically built very lightweight and very specific for the application or the service that it's running. And then Kubernetes sits as a CAS, so think of this as like a containers as a service. So I've moved past the Docker run stage, and now I'm up to more of the I have thousands of containers or hundreds of containers, and I need to know how to manage them, right? And so this is where a CAS orchestration framework like Kubernetes steps in. So some core components. The first one we'll start off is everything in Kubernetes starts off as a cluster. And part of that cluster really contains, a master node and then X amount of worker nodes. This is how big you want your cluster to be. What we want to do from a VMware perspective, if you were at the keynote this morning, is we want to serve up Kubernetes as a dial tone service within vSphere with PKS. So if you need a Kubernetes cluster, you should be able to, as a vSphere admin or a cloud admin, submit a simple API call or go to a UI and say go, and this is what it's actually going to spin up. Masters are typically rolled out in a HA scenario with front-ended by a load balancer, and then you'll have your worker nodes that will communicate with the master to actually schedule the workloads on top of them. The cluster can be broken up into different Kubernetes namespaces, and this is just kind of a logical grouping, right? Where I may have developers that are only allowed to go into like a test dev namespace, and then I have a production namespace, but all of the workers are actually shared among all namespaces. I can't selectively say these workers are part of this namespace and then X workers are part of another, right? They're completely shared resources across all namespaces. So if you need to actually have SLA requirements, it'd probably be better just to spin up another cluster. And that also goes true if you're going to have different sites. I got this question yesterday. It's like, well, how do you span across sites? And again, the answer is going to be, you're going to spin up another cluster at each site, right? And so that's why we make it very simple to deploy a Kubernetes cluster from a vSphere admin or a cloud admin perspective. So if we dive into the master, what are the different components and what is acting as this? And think of the master, if you're relating this to vSphere constructs, think of the master as vCenter, right? And so it has some of the same constructs inside of this. The first one being an API server. So inside each master, there's an API server. This is going to either take requests from kubekettle. So if I'm using the Kubernetes binary kubekettle, I'm going to hit the API master, and that's going to schedule whatever type of spec that I'm submitting to the API. This can also it's a REST API, so you can also submit REST commands to the API server as well. The scheduler, it acts just like DRS, so each one of the workers are submitting back how much available resources they have on a regular basis. And so the scheduler is actually going to use this statistics and say what workloads are available for which worker nodes. It acts just like DRS does for placement of VMs. Instead of this, it's doing placement of what are called pods, right? So the next piece is a UI. Kubernetes does have a UI, so you can log into the UI, see all your worker nodes, see everything that's been deployed, like replica sets and pods and constructs that we're going to talk about here. But you can just go in, look what's happening, see if a node is down or not, kind of see the health of everything that's happening inside of the environment or inside of the cluster. The controller manager is everything else, right? It's kind of like the garbage collector. It's like, well, where am I going to put everything? So the replication controller is in here. How I deploy daemon sets is also in here. So anything that's not in the API server and the scheduler, they just throw in the controller manager. This may change shortly. They're trying to like make, Kubernetes is a very modular framework and they're trying to keep it that way. But that's why the controller manager is kind of fat up there, because everything else is just being pushed into the controller manager, but that may change in the future. So the worker node, right? When we have a worker node, if we expand that out, the worker node consists of basically 3 concepts. The first one's going to be the kubelet. So the kubelet is an agent that runs on every single worker, and it's going to respond to a couple of different things. So it's going to do health checks. So Kubernetes is always monitoring the health of a worker to say, hey, are you there? Are you running your pods? So on and so forth. And it's also in charge of running the pods that are scheduled to that specific worker. So it's always watching. Everything in Kubernetes is a watch service. And so the worker, specifically the kubelet, is going to watch for pod specs. And so when it sees a pod spec that says, hey, I need to run this pod, it's going to spin up that pod inside of that worker. Okay? If the worker goes down, then it's up to the master to say, hey, kubelet's not responding for X amount of seconds. It will schedule those pods on other workers within the cluster. The next one is the kube proxy. So the proxy is actually how we interact with the different pods inside of the cluster, right? I need to be able to have access to these pods, and that happens through kube proxy. And kube proxy manipulates IP tables within each worker to provide things like cluster IPs and endpoints, and uses some rudimentary load balancing within the Kubernetes cluster. So if I have pods that are scheduled on that, and I go to a cluster IP, regardless if they're on that worker node or not, the kube proxy can hit a certain IP, like a cluster IP or a node port, and it'll go to that specific pod in the end. And we'll talk about how that works here in a second. Next piece is obviously a container runtime. I actually need something to run the containers, right? And this is typically Docker that runs underneath it, but Kubernetes is actually just going to talk to Docker through what's called like an OCI compliant API, right? Think of it like, in OpenStack you have plugins or drivers. Kubernetes works in the same way, right? Where you've heard the term probably even from Docker, batteries included but replaceable. Well, Kubernetes works the exact same way. If you want to use Flannel as a network plugin or NSX as a network plugin, you're more than welcome to do so. You'll just have to comply to the CNI requirement, right? So the network interface for the networking. Same thing with container runtimes. You can use any runtime you want. Typically, it's going to be Docker, though, inside of your cluster. So some basic concepts. You've heard me say the word pod. What is it? So I can't schedule a container in Kubernetes. I have to schedule a pod. Okay? And a pod is a grouping of one or more containers. Typically, it could be one-to-one, or it could be one-to-many. A pod, though, is a very tightly coupled framework, right? It shares things like namespaces, like IP addresses, things like local host. So RPC is shared. And a pod is always scheduled on a worker. So if I have a pod with 5 containers, that pod will be on a very specific worker. I may have many pods of the same type, but one pod is a one-to-one relationship between a pod and a worker. Okay? They also share the same data volumes. This is very specific. So if I have a very, again, tightly coupled application that needs to share data, I may schedule them in a pod that's, so I can get access to the same data. Typically, though, this is linked with something like logging, like I have up here. So some tools around, maybe I have Nginx, and then I have Wavefront, where it's grabbing all of the Nginx logs. And a lot of times, pods are scheduled one-to-one. So one pod, one container, right? But it doesn't have to be. Pods are also considered obviously ephemeral, just like containers. So when the pod goes away, so does all the data inside of that. And so that's why persistent volumes are extremely important in this regard. Labels as well. So I want to label my application, and labels are used for multiple different things. And here the example is, my Nginx is going to be tier front end, the app equals my app, and then I have the back end, my Redis back end, but again tier back end, but my app is the same, right? And so each application that you want to label this. And it's used for multiple different things as far as like firewalling, as far as replication, as far as like services and accessing this. And it's very valuable metadata that, to have labels inside your Kubernetes cluster. Okay. Persistent volume claims, this is going to be what a little bit of two onus, right? You're going to have administrator owned and then developer owned. So the provisioning portion is going to be backed by some type of data store. They're going to provision a Kubernetes cluster. They're going to register a persistent volume class inside of this. And then they're going to, the developers then can request a persistent volume claim. It's going to spin up that claim inside of the worker and attach it to that pod. And then I can have the developer release the claim, and then the administrator can actually reclaim that provision storage. So if the developer releases the claim, it's not going to actually provide the storage back to me until the administrator goes in to reclaim it. Services, this is what I'll end on here. And so this is exactly how we access our applications. And so I have my node IP of 10.10. This is going to be my cluster IP of 3.14. I also get native DNS. So the DNS is going to be service1.cluster.local. So my pods can access each other either over 3.14 or that DNS name. Right, and so I want a constant IP address, and a service gives you that constant IP address to talk to the pods. Pods will spin up, automatically all the time, and I want to actually provide that constant IP, and that's what a service does. And so it's going to provide native east-west load balancing to my cluster and to my pods inside of that. Okay. It's also going to provide DNS and environment variables where I can have my application grab those, interact with them as far as spinning up Nginx. So that's all I have. I have 15 minutes. I'll cover the rest here in another session here, and I think in another 15 minutes.